Hi, everybody. This is one of the sections where I receive a lot of emails. A lot of students struggle with knowing how to find the permutation and the combinations. I should correct what I just said. They don't necessarily struggle with how to do permutations and combinations. A lot of students struggle with knowing when to use which. So that's what I want to address in this video. I'm going to do quite a few examples like I've been doing in the past. So what we're going to do is try to determine when to use a permutation and when to use a combination. And we're going to solve applications using permutations and combinations. Okay, so you already learned in the previous video in the previous sections of the textbook about permutations and combinations. You should already know what the formulas are and know how to do those in your calculator. So if you were doing them by hand, you would use this formula for a permutation, the permutation of n things taken r at a time, and if a combination of n things taken r at a time, which the formulas are written here for you if you're going to do them by hand. Remember to find them on your calculator. They're under the math key and probability, and you have NPR and NCR. Okay, I'm not showing you how to do that in this screencast. I showed that in the other one. What I'm going to show you is some examples. So for permutations and combinations, here's an example. From a committee of 10 people, in how many ways can we choose a chairperson, a vice chairperson, and a secretary, assuming that one person cannot hold more than one position? In this example, these people are given specific titles. So who they are matters. We're not just picking three random people. We're picking a chairperson, a vice chairperson, and a secretary. Since the order matters, since the people are specific, then we have a permutation. And this is a permutation of 10 taken 3 at a time. And so that answer would be 720. Okay, for part B, that's a combination. It's a combination because it says, in how many ways can we choose a subcommittee of 3 people? So those 3 people are just 3 people. Tom, Dick, and Harry are going to be 3 people in our committee. Whether I pick Tom first or Harry first doesn't matter. That's different for the permutation because Tom being the chairperson is different than Harry being the chairperson, right? Okay, let's go to the next example. Oh, sorry, I forgot to show you the answer. The combination of 10 taken 3 at a time is 120. Okay. So the next examples have to do with a deck of cards. You're going to have a lot of questions about cards. It's going to be on your final, and it's going to be on your tests, both in this section, in this chapter, and in chapter 8. So remember, if you have a deck of cards laying around in the house, look at it if you're not familiar with them. So these are the hearts, these are the clubs, the spades, and the diamonds. We call these cards the Jack, Queen, and King face cards. Okay, so from a standard deck of 52 cards, we're going to go through 4 examples on this page. How many 5-card hands consist entirely of red cards? This is a combination. We're just getting a hand of red cards. The order they get in our hand doesn't matter. So it's a combination, right, of how many cards taken, how many at a time. So we have the group of red cards, which are these and these. If you add those together, that adds up to 26. There's 13 cards in each suit. So there's 26 cards, and we want 5 of them. So it's the combination of 26 taken 5 at a time. How many 5-card hands consist entirely of clubs? Well, here are the clubs. There are 13 of those. So it's 13 taken 5 at a time. The next question. How many 5-card hands consist entirely of face cards? Well, the Jack, Queen, and King in each suit are face cards. So there are 12 of those. And we're taking 5 of them. So that answer is 792. So these 3 questions were similar, just little variations in them, but this one is a little bit different. It says, how many 5-card hands consist of 4 queens? Well, if you're taking all the queens, you have all the queens in your hand, but you have a 5-card hand. So you have one other card that you have to have in your hand. So that's going to be the combination of 4 taken 4 at a time, which is actually 1. There's only one way to get all the queens, times 48, because there are 48 other cards that can be that other card, right? You have the 4 queens, and 52 minus 4 is 48. And so there are 48 cards, so we have 48 choices. Okay, here's another one that's a little bit more complicated. How many 7-card hands consist of 4 aces? Okay, so you're getting those 4 aces, but then you have 48 cards to pick from for the other 3 cards. So this is how we get the aces. There's only one way to do that. And then there are 17,296 possibilities for a hand that has 7 cards in it. 4 of them aces, and the other 3 are what is left in the deck. All right, try this one. How many 7-card hands consist of 3 hearts and 4 diamonds? So how many hearts are there in the deck? That answers 13. How many diamonds? That answers 13. So it's the combination of 13 taken 3 at a time. That's how we get the hearts. And 13 taken 4 at a time. That's how we get the diamonds. And you can type that just like that in your calculator. The answer is 204,490. Okay, my last example that I want to do is this example from quality control. You're going to see this a lot in Chapter 8 as well when we're talking about complements, and you'll see that later. But let's start this and build the foundation in this problem. So, an office supply store receives a shipment of 24 high-speed printers, including 5 that are defective. 3 of the printers are selected for a store display. How many selections can be made? That's the first question. And the second question, how many of these selections will contain no defective printers? So first, let's tackle the first question. How many selections can be made? Well, how many printers are there? 24. And how many are you selecting? 3. So that's a combination of 24 taken 3 at a time. There are 2,024 ways to make this selection. Now, what if those selections contain no defective printers? Well, how many printers are not defective? Well, 24 printers is how many we have, and 5 of those are defective. 24 minus 5 is 19. So there are 19 computers that are not defective. We're going to choose 3 from that group that are not defective, and that number is 969. Okay, I hope this little video helped. I tried to show you a lot of examples. Please feel free to email me if you still don't understand it. I'm really happy to help. Have fun with this. Don't be intimidated. These can be a lot of fun. If you make a mistake, no big deal. Work it out, walk it backwards, see where you went wrong, and make sure it makes sense to you. I'm looking forward to your questions this week.